The last section of chapter 3, and it's about perpendiculars and distance. The first thing we want to discuss is the distance between a point and a line. So when we look at this, we have a point and we have a line, and what we have is that the distance between a line and a point not on the line is the length of the segment perpendicular to the line from the point. Now you can have any number of segments that go from the point to the line. I could have a segment that comes over here. I can have one that comes down over here. I can have all kinds of segments. But none of these will represent the distance. Only one segment will represent the distance, and that is the segment that comes straight to a 90-degree angle and is perpendicular. This length will equal the distance from this point to this line. And this works together with the perpendicular postulate to give us some more things that we can do. The perpendicular postulate tells us that if a line and a point not on the line, so if you're given a line and a point not on the line, we have a line, we have a point, there exists exactly one line, so only one, through the point that is perpendicular to that line. So again, we can have lines, and we can have, in essence, an infinite number of lines that will go through this point and this other line. We can have them from kind of all over the place, and as long as they're not parallel, that one doesn't even go through one point. As long as they're not parallel, they'll go through the line. But only one line will exist that will go through that point and will be perpendicular to the line. None of these red lines count. It's only the perpendiculars that we're looking at. So you may need to pause the video to write this down at this point. Otherwise, we'll move on. Okay, so we want to be able to find that distance. Oops, this line should not be there. We want to be able to find that distance. And we're given some details. Line L contains these 2 points, -5, 3, and 4, -6. And we want to find the distance between line L and some point P. So there are steps we can follow in order to do this. Step 1 is find the slope of the given line. And we can do this in two ways. The first way we can do it was with a picture. So we're going to actually plot the points. I have -5, 3, and then I have 4, -6. So 1, 2, 3, 4, 2, 3, 4, 5, 6. Okay. And then I'll draw the line between those 2 points. And then I can count the slope. So to get from this point to this point, first I go down. I go 1, 2, 3, 4, 5, 6, 7, 8, 9. So I go down 9. And then I go over 1, 2, 3, 4, 5, 6, 7, 8, 9. So I went over 9. So my slope from the picture is -9/9, which is the same thing as -1. Or I can use the formula. So remember, I subtract the y's over top of subtracting the x's. That's a 1, and they go in order. So y2 is -6 minus y1, which is 3, over x2 minus x1. Double negative is a positive, so I get negative 9 over positive 9, which gives me negative 1. So either way you want to find the slope, that's fine. You can use a picture or you can use the formula. The next thing we want to do is write the equation of the line perpendicular to the given line. Okay, so if our original slope is negative 1, our perpendicular slope is going to be the reciprocal. Well, negative 1 over 1, perpendicular is opposite and upside down, so it would be positive 1 over 1 or just 1. So our perpendicular slope is 1. Our point P is the point 2, 4. So if I plot that 2, 1, 2, 3, 4, P exists right here. Okay. Then we have a line that will go perpendicular. I need to find that line. So I'm going to plug in to the y equals mx plus b. And the reason I can't use the point slope form, I have to use y equals mx plus b, is because I only have one point. I need 2 points to be able to use. Well, I guess I could use point slope form, but you'd want to convert it. Anyway, I'm going to use y equals mx plus b. My y is 4, my slope is 1, my x is 2. I need to find b. So 4 equals 2 plus b. Subtract 2 from both sides, and I get that 2 is equal to b. So my equation is y is equal to 1x plus 2, or just x plus 2. This is the line that's perpendicular. Okay, so the next thing I need to do is I need to find the point of intersection, so the point where the two lines cross. Well, I know that I'm going to hit here at 2 because 2 is my y-intercept. And I know my slope is 1, so I'm going up 1 over 1, up 1 over 1. So I can go down, back, down, back. So I can find the point of interception graphically. So we'll do that. Step 3, find intersection. And you have two choices, one with a picture and one is with a system of equations. Okay, if I use the picture, I want to connect my dots, and I'm going to intersect at this point right here, which is negative 2, 0. And I know that worked because it lined up, but it doesn't always line up. So right here I can have my point of intersection as negative 2, 0. However, if not perfect, you must use a system of equations. So we're going to need to use a system of equations. I'm going to show you how to do that just to solve it, which means we need the equation of the first line as well. So okay, the equation of the new line is y equals x plus 2. The equation of our first line, here's our y-intercept on this one, so we get y equals negative x minus 2. If we were not able to find that graphically, we'd have to plug in the slope and a point to solve for b. Okay. Once we have our two equations, I have y equals negative x minus 2, and I have y is equal to x plus 2. Okay. If I solve this system by addition, I get 2y is equal to, because y plus y is 2y, negative x plus x goes away. That's why I went ahead and used addition, because these are already opposite. And negative 2 plus 2 goes away. So I get 2y is equal to 0, which means that y is equal to 0. Then I plug that in. So if I say y is equal to x plus 2, I have 0 is equal to x plus 2. I subtract 2 from both sides, and I get that negative 2 is equal to x. And so we still get the same point of interception, this negative 2, 0. So you've got those two ways to find the point of intersection. You can either find it with a picture if it works out, or you can find it with a system of equations. Now at this point, I have to do the last step. And I find the distance between P, which was 2, 4, and the point of intersection. Which was negative 2, 0. We use our distance formula for that. Minus x2 squared plus y1 minus y2 squared. Doesn't matter which one we say is x1 or which one we say is x2, just so long as we're consistent. So I get 2 minus negative 2 squared plus 4 minus 0 squared. 2 minus negative 2 is the same thing as saying 2 plus 2. And 4 minus 0 is 4. So I get 4 squared plus 4 squared, which is 16 plus 16, which is the square root of 32. And that is about 5.66. And so that's the distance between the point P and the line L. Here's my final answer. Okay, we're going to try another one. Try to move a little slower through this one. We've got line M, which contains the points 3, 2, and negative 4, negative 1. And we have point P, which is 5, 5. So the first thing I'm going to do is get my x and y axes. Then I'm going to plot the points for line M. So I have 3, 2, and negative 4, negative 1. And I'm going to connect those dots. Okay, and then I'm going to count the slope. And to get from here to here, I'm going to go up 1, 2, 3. So up 3, and then over 1, 2, 3, 4, 5, 6, 7. So step 1 is the slope, and I get 3 over 7, so 3/7. Again, to find that using the equation, So I'll have negative 1 minus 2 over negative 4 minus 3, which will give me negative 3 over negative 7, and two negatives make a positive. Now, I'm not convinced that I'm getting a perfect point right here. So before I get into step 2, I'm going to find the equation. So I have y is equal to mx plus b. So I can pick either y, so I'm going to do 2 is equal to 3/7 times 3 plus b. So 2 is equal to 9/7 plus b. I'm going to change this 2 into 14/7. So remember, if you want to make a common denominator, you just multiply the whole number by whatever denominator you want. So 2 times 7 is 14, so this is 14/7. I subtract 9/7 from both sides, and 14 minus 9 is 5. So the equation of this line is y is equal to 3/7 x plus 5/7. So see, this one's not working out perfectly, so I do have to use the steps, the algebraic way of finding the equation. Okay, step 2 is perpendicular line equation. Okay, my point P is at 5, 5, so I've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so I want to find the perpendicular line that'll cut through right here, so I can find the distance. I know my original slope is 3/7, so my perpendicular slope is going to be opposite, so negative, and upside down, so negative 7/3. So I'm going to have y, which is 5, is equal to negative 7/3 times 5, because that's x, plus b. So negative 35/3 plus b. 5 is 15/3. So I'm going to add 35/3 to both sides. And I'm going to get that b is equal to 50/3. So this equation is y is equal to negative 7/3 x plus 50/3. Okay, I'm going to go ahead and graph the line. I already know a point on the line, so I can go down 7 and over 3. So I go 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. And here's another point. So this line is going to cut between these 2 points like this to be perpendicular. And the length I'm looking for is just this little segment right there. Okay, so I have my 2 equations. Y is equal to 3/7 x plus 5/7. So I'm going to write that down. And y is equal to negative 7/3 x plus 50/3. Now this system is going to be ugly to solve because of all these fractions. So I'm going to get rid of fractions. I'm going to multiply each by the denominators. Okay, so this one I'm going to multiply by 7. And this one I'm going to multiply by 3. Now this 7 gets multiplied times everything, the y, the 3/7 x, and the 5/7. What that does is gives me 7y is equal to, the 7's cancel, so I'm left with 3x, and the 7's here cancel, plus 5. Here, 3 times y gives me 3y. The 3's cancel, so I get negative 7x. And the 3's cancel, so I'll have 50. Now I need to decide if I want to get rid of the x's or the y's. I'm going to choose the x's because one's already negative and one's already positive. So if I multiply this whole equation by 7 again, and this whole equation by 3, I'll get positive 21 and negative 21, and so they'll cancel out completely. So 7 times 7 is 49. 7 times 3 is 21. 7 times 5 is 35. 3 times 3 is 9. 3 times negative 7 is negative 21. And 3 times 50 is 150. Now I can add these together and my x's will cancel. 49 and 9 is 58y is equal to 185. Now this is not going to divide evenly. I'm, almost 100% sure. It will surprise me if it does. I'll divide both sides by 58. And I'm going to get that y is equal to 3.19. I'm rounding. It's actually 3.189655172, but I'm going to round 3.19, which I'm then going to plug in to find an x. And it doesn't matter which one I use, so I'm just going to use the top one. And since I have a decimal over here and fractions on this side, I'm going to convert these fractions to decimals. So I'm going to do 3 divided by 7 and 5 divided by 7. So I'm going to get 3.19 is equal to 0.429x plus 0.71 4. I'm going to subtract 0.714 from both sides. So 3.19 minus 0.714 gives me 2.476 is equal to 0.429x. I'm going to divide both sides by 0.429. And I'm going to get that x is equal to 5.77. So this is the point of intersection, 5.77 and 3.19. Okay, once I have that, I have my original point P, which is 5, 5, and I have my intersection point, which was 5.77 and 3.19. And I want to find the distance between them. So I'll use my distance formula. And I'll have 5 minus 5.77 squared plus 5 minus 3.19 squared. So I'll have negative 0.77 squared plus 1.81 squared. Now when you square a negative, you get a positive. So I'll have 0.5929 plus 3.2761 adding those together, I get the square root of 3.869, and I take the square root of that, and it gives me 1.97. So the distance is almost 2. Okay. Once we've got that, we have some more sort of definitions. Parallel lines do not intersect. They're equidistant in all places, which means if I have these two parallel lines, so I'm going to mark these so that they show that this is parallel. The distance AF will be the same as the distance BG, which will be the same as the distance CH, which is the same as DI, which is the same as EJ. No matter where I go on the line, and these will all be perpendicular, if I find the distance between the two parallel lines, it's the same. Okay, the distance between two parallel lines is the perpendicular distance between one of the lines and any point on the other line. So I take a line and I go perpendicular to the other line, and this gives me the distance. This length here is the distance. Okay. We also have another theorem. Two lines are equidistant from a third. So in a plane, if two lines are each equidistant from a third line, so if I come through and I have a perpendicular here, and then I have another perpendicular here, and I say that this distance, this length is, say, x, and this length is also x. So I call this line L, M, and N. If the distance between line L and M is the same as the distance between lines M and N, then L is parallel to N. So we can tell if two lines are parallel to each other if they're the same distance from another line. Okay, so we want to find the distance between parallel lines L and M if the equations for the lines are y equals 2x plus 1 and y equals 2x minus 3. Now I know they're parallel because the slopes are the same. If the slopes aren't the same, they're not parallel. So what we want to do sorry about that. The first thing we want to do is graph the two lines. So again, I'll bring in my x and y axes. I'll graph this line in red and this line in blue. So for my red line, my y-intercept is positive 1, and my slope is 2, so that's the same as 2 over 1, so I go up 2 over 1. And since I don't have a ruler, I'm just going to draw a lot of dots to sort of keep this in good proportion all the way through. Gives me some guidelines to follow. Okay, so the equation of this, or the graph of this equation, is this line here. Now in the blue one, my y-intercept is negative 3. So I'm starting at negative 3. And then I have the same slope, so 2 over 1. And again, I'm just putting in a bunch of dots to give me a guideline to follow. so that I'm accurate. Okay, this didn't work quite well. Okay, so I've got my two parallel lines. That's step one. Step two is to go to the y-intercept of either line and graph a perpendicular line through that point. So I can go to this y-intercept or this y-intercept. I'm going to go ahead and go to the top y-intercept. So that's my y-intercept. My slope original is 2, so my perpendicular slope is going to be opposite, so negative, and upside down, so 1/2. So I'm going to go down 1 and over 2. Down 1 over 2, down 1 over 2, etc. And then I'm going to graph that line. So this line is perpendicular, so I'm going to call it line P for perpendicular. My red line was line L, and my blue line was line M. Okay. So that was steps 1 and 2. We were drawing the pictures. Step 3 is to find the equation of line P. Well, that's not too bad because we already know what y-intercept we chose. We choose either y-intercept. We chose 1. So we know that B is equal to 1. And we know the perpendicular slope, negative 1/2. So the equation is y is equal to negative 1/2 x plus 1. Okay, so we've got the equation, and we know the intersection, we know the point here, we need to find the intersection of L, or P and M. Okay, so I know the equation of line M, so let's see, step 4 is to find solution to the system of P and M, so the other line, because we use the intercept for L. You can see it's not crossing at a perfect point, unfortunately. So we're going to solve that system of equations. I have y is equal to 2x minus 3, and y is equal to negative 1/2 x plus 1. Now, none of my coefficients will already cancel, but I can turn this negative 1/2 into a negative 2 if I multiply this whole equation by 4. And so I'll have y is equal to 2x minus 3, and 4y is equal to negative 2x, because 4 times negative 1/2 is negative 2, plus 4. I'll add those together, and I'll get 5y is equal to 1, so y is equal to 1/5, which is 0.2 if you want to use decimals. And if I plug that in, I get 0.2 is equal to 2x minus 3. Add 3 to both sides, and you get 3.2 is equal to 2x. Divide both sides by 2, and you have x is equal to 1.6. So I now have 2 points, and I can find the distance between them. So that's step 5. Find the distance between the y-intercept on line L and the intersection on line M. So I have the 2 points. My 2 points were 0, 1, and 0.2, 1.6. So I have to use the distance formula. So I have 0 minus 0.2 squared plus 1 minus 1.6 squared. So that gives me negative 0.2 squared plus negative 0.6 squared. And again, when you square negative, they become positive. So I have 0.04 plus 0.36, which gives me the square root of 0.4. Which is about 0.63. And so that's how we find the distance.